Bismillahirrahmanirrahim. In this video we will do example 5.4, which says that repeat 5.3 if the message signal is time expanded by a factor of 2, that is the time period has become double. Now the amplitude is same, which is 1 and minus 1 as was in the case of example 5.3, but the time period has become double. The time period in the first case was 2 multiplied by 10 raised to power minus 4. Now the time period has become double and it is 4 multiplied by 10 raised to power minus 4. Now when the time period has become double, the fundamental frequency is again going to be 1 by t, that is 1 divided by 4 multiplied by 10 raised to power minus 4, which comes out to be 2.5 kilohertz. Again we are going to take the third harmonic because the second harmonic is an even harmonic that is equal to 0. And the fifth harmonic has very smaller amplitude as compared to the third harmonic. So we are going to take the third harmonic. So it means that we are going to take 3 multiplied by 2.5 kilohertz, which becomes equal to 7.5 kilohertz. So the bandwidth of the message signal will be taken as 7.5 kilohertz. Now we need to calculate the FM bandwidth and the PM bandwidth because that's what we did in the previous example. So the FM bandwidth again is equal to 2 into delta F plus B, where delta F again is going to be equal to KF MP divided by 2 pi, where MP is the maximum amplitude of the message signal. So this will be equal to, because delta F is equal to 2 pi multiplied by 10 raised to power 5 and MP is equal to 1 and this will be 2 pi. So this delta F will be equal to 100 kilohertz. So I'm going to put in here, this will be 2 into 100 plus 7.5 kilohertz. So this will be 2 into 107.5 kilohertz, which means that I am going to get 215 kilohertz. In the previous example, if you remember, when there was no time expansion, we got the FM bandwidth of 230 kilohertz. So there is not much effect of the time expansion on the FM bandwidth. The time expansion of the FM bandwidth, the time expansion of the message signal has very little effect on the FM bandwidth. But let's see the PM bandwidth, that is the phase modulated bandwidth. That again is going to be equal to 2 into delta F plus B. We are going to use the same equation where B again is 7.5 kilohertz. Again delta F is going to be equal to Kp MP divided by 2 pi. But in this case MP is the maximum amplitude of the derivative of the message signal. MP is the maximum amplitude of the derivative of the message signal. So we need to take the derivative of the message signal. For that, first of all, we need to find the equation of this line. Let's first find the equation of this line. Now the total is 4 multiplied by 10 raised to power minus 4. So this point will be 2 multiplied by 10 raised to power minus 4 on the x-axis. Let's suppose this is my 0. So this point is my 0, 1. This point is my 0, 1. And this point is my 2 multiplied by 10 raised to power 4 and minus 1, because this equals to minus 1. This is x, this is y, this is x, and this is y. So now the slope of this line will be equal to y2 minus y1 divided by x2 minus x1, which means that y2 is equal to minus 1 and y1 is 1. y1 minus 1. This is minus 1 and this is 1. x2 is 2 multiplied by 10 raised to power minus 4 and x1 is 0. So we are going to get the slope minus 2 divided by 2 multiplied by 10 raised to power minus 4, which equals to the minus 10,000. So the equation of this line is going to be equal to y is equal to minus 10,000 t plus c. And if I take its derivative, y bar is going to be equal to minus 10,000. Because this is my message signal, actually y is my message signal m of t. So this is actually the maximum, this is actually the minimum value of the message signal. And the maximum value will be, because the equation of this line will be then y is equal to 10,000 t plus c. So the maximum value of this message signal, of this derivative of the message signal, will be equal to 10,000. So that's why MP will be equal to 10,000. So it means that MP is going to be equal to 10,000. So this will be Kp is equal to 5. This is 5 pi multiplied by 10,000 divided by 2 pi, which comes out to be 25,000. So 25 kilohertz. And then I'm going to do the replacement in this equation, the phase modulated wave. So this comes out to be 2 into 25 plus 7.5, which comes out to be 65 kilohertz. In the previous example, when there was no time expansion, the phase modulated bandwidth was 130 kilohertz. So now it has become half. So the time expansion of the message signal has very little effect on the FM bandwidth, but it halves the PM bandwidth. The PM bandwidth has become half. This verifies the observation that the PM spectrum is strongly dependent on the spectrum of the message signal. So the phase modulated spectrum is dependent on the spectrum of the message signal, spectrum of message signal M of t, whereas the frequency modulated wave is almost independent on the spectrum of the message signal, or very little dependent on the spectrum of the message signal. Thank you.